In this video, we're going to start looking at integrating inverse trig functions. This can be found in your class's Google Drive folder. However, if you want to copy these formulas down, please do so. You can pause the video while you copy those down. Let u be a differentiable function of x and let a be positive. In our first example, if you have to check the format, notice that in the denominator we have square root of a number minus x squared. In the top three inverse integral functions, we have the format for rule number 1, which integrates as an arcsine or a sine inverse integral. The key is trying to mock the formula given. For example, 6 is square root of 6 squared. X squared is x squared. So you can tell that your a value is square root of 6 and your u value is x. Because this rewriting gives us exact values for a and u, when we integrate, we can use the formula up here, and that is arcsine of our u value, which is x, over the a value, which is square root of 6. And don't forget your constant of integration. So really the key is to mimic one of these integrals as closely as you can, and then you just integrate once you know your u and your a value. In this one, we have the integral of 1 over x times the square root of 4x squared minus 1. 4x squared can be written as 2x quantity squared. If you were to multiply back out, 2x times 2x is 4x squared. 1 is also 1 squared. And so now we know u. And if you have to refer to your integral formulas, go back up and look. This is the arcsecant formula. We have the square root of u squared minus a squared. To the side, u is 2x. Its derivative is 2dx. Because we need to mimic dx, we can divide by 2 and rewrite dx as 1/2 du. Under the radical, this will be square root of u squared minus a squared. Notice that 2x, once we use the 1/2 du, that 2 multiplied with x recreates our u value. And so now we can change 2x to u, and we've done a total swap out from the original terms to terms of u. Our integral formula is 1 over a arcsecant absolute value of u over a, and now we have values back up here for all of that. So we have 1 over a was 1, arcsecant absolute value of u, which is 2x. Again, a is 1. Everything's filled in, and on the last step we simplify. That is arcsecant of 2x, make sure it stays the absolute value, plus c. Integral of 16 over 1 plus 4x squared. 16 is a scalar multiple. I'm going to pull it out front of the integral. 1 is 1 squared. 4x squared is 2x quantity squared. If you go back to your integral formulas, this is tangent inverse integral. A is 1. U is 2x. Derivative of u is 2dx. Mocking dx, that's 1/2 du. The fraction we already know, that's 1 over a squared plus u squared. It's the dx that we have to translate to 1/2 du. There's my du, and that's the 1/2. times the 16 that we pulled out front yields an 8. This is our integral formula involving u's and a's, and now we plug back in. A was 1, u was 2x, a is still 1, and simplifying, that's 8 arctan. You could also write tangent inverse of 2x plus c.